Here we are given a rational function f of x equals 2x minus 1 all over x plus 4, and we're asked to determine f inverse of 3. So one strategy would be to use our switch and solve plan and actually come up with the inverse function and then evaluate it at 3. Because this is a little bit more complicated function, it takes some work to find that inverse function. So instead, I just want to think about how we can use the original function to find information about the inverse. So if we're trying to find f inverse of 3, we want to know what that value, that output is going to be. That means that on the original function, f of whatever that value is must be equal to 3, because remember, for a function and its inverse, the inputs and the outputs have been switched. So if we want to know f inverse of 3, it's the same as asking the question of what input in the original function would give us an output of 3. So if we're trying to determine when f of x would be equal to 3, the original function would be equal to 3, we can find that by doing a solve of when is 2x minus 1 all over x plus 4 equal to 3. So if we solve this equation for x, this will tell us the input on the original function that gives us an output of 3, which will tell us the output on our inverse function. So let's go ahead and look at how we can solve this. I'm going to start by eliminating the fractions, and I can do that by multiplying both sides by x plus 4. So we have that 2x minus 1. Distributing, we have 3x plus 12. I'm going to go ahead and subtract 2x from both sides. So we have negative 1 is equal to x plus 12. Subtracting 12, we get that x is equal to negative 13. So think about what we have found. We have just found that for the original function, f of negative 13 is equal to 3. An input of negative 13 gives us an output of 3, which means that f inverse of 3 is equal to negative 13. So notice that from a function to the inverse, the input became the output became the input. So to answer our question, f inverse of 3 is equal to a negative 13.